In section 3 of chapter 7, we're going to continue with where we left off. We've been dealing with radicals. We've been dealing with the multiplication of radicals, simplification of radicals. Now we're going to deal with the addition and subtraction of radicals. I only have one slide of notes because the way we add and subtract radicals is relatively simple. In fact, you've seen it before, but I want to review it now. There are two rules of radicals when it comes to addition and subtraction. Radicals can only ever be added or subtracted to one another if two things occur. The index of the radical, that is to say the type of radical it is, they have to be the same. So you can only add a square root with a square root. You can only add a cube root with a cube root. You can only add a fourth root with a fourth root. A square root and a cube root cannot combine together through addition. That's the first thing that has to happen, same type of radical. Second thing, the value underneath the radical must be the same. So if I have a square root of 2, it can only add together with something that has a square root of 2. A square root of 2 and a square root of 3 cannot combine together through addition. If those things occur, you can treat them like a variable. So for problem number 1, it is 3 root 2 plus 5 root 2. You can think of this as the same thing as me saying, what is 3x plus 5x? Because the variables are the same, you can add the leading coefficients, the 3 and the 5, and just be left with 8x. That's my answer to this made-up example. We treat that problem that I have in red the same. I have 3 root 2 plus 5 root 2. These are the same type of radicals with the same indexes and the same value for their interiors. So I just simply add their leading coefficients, the 3 and the 5, to get 8 root 2. Problem number 2, same thing. I have 7 root 5x minus 11 root 5x. Even though there's variables, we treat it exactly the same. It's the same type of radical with the same interior values. So I'm just going to take 7 minus 11, which is negative 4, and then I just combine it with the root 5x. That's my answer. Now these first two problems are relatively simple. The next two are a little bit more complex. Problem number 3, I have 3 times the square root of 18x cubed minus 7 times the square root of 2x plus 3 times the square root of 32x. As they are currently written, nothing can add or subtract to one another because the radicals are all different. However, each of these radicals, except for the middle one, mainly the last two radicals, are simplifiable because 18 is the same thing as 9 times 2. And then 32 is the same thing as 16 times 2. The square root of 9 is 3, so I can pull that 3 out. I also have the square root of an x cubed, so I can pull an x out as well, which is what we learned in the last section, leaving you with just 2x underneath the radical. The next one, the square root of 16 is 4, and the 2 and the x cannot move out of the radical, so they stay as is. Then I multiply the exteriors. 3 times 3x is 9x. And then 3 times 4 is 12. Here's the other twist this problem has. Now all of the radicals are the same. They're all square roots. They're all the square root of 2x. However, this is a 9x. This can only combine together with something else that has the x on the outside. Neither of these do. So even though they all share the same radical, because this has a variable on the outside that doesn't match with anything else, this has no like terms. So the radicals must be the same, but also if there are any variables, they must also be the same. Therefore, this is just going to turn into 9x root 2x plus 5 root 2x. That is our solution to problem number 3. Problem 4, you've dealt with problems like this before. We're just multiplying before we can start adding things together. So I'm going to take that binomial and multiply it by the other binomial using FOIL. I'm going to take the first term and multiply it by the first term. 2x times 6 is 12x. Root 3 times root 2x is root 6x. Then I take that first term of the first binomial, multiply it by the second term of the second binomial. 2x times, there's an invisible 1 in front of that root 3, or negative 1 I should say. That's going to give me negative 2x root 9. And then I'm going to take the second term from the first binomial and multiply it by the first term of the second binomial, and I will get plus 6 root 2x. And then I'm going to multiply the second term of the first binomial by the second term of the second binomial, and that'll get me negative root 3. I simplify those as much as possible. The square root of 6x in the first term can't simplify. The square root of 9 in the second term would turn into a 3. And 3 times negative 2x is going to give me negative 6x. The root 2x doesn't simplify, so that's still plus 6 root 2x. And the root 3 doesn't simplify. In order for this term to combine with anything, I would need a root 6x, and I would need an x on the outside. That does not occur. In order for this to combine with anything, I would need no radicals, just an x. That doesn't occur anywhere else. In order for this term to combine with anything, I would need a root 2x and no variable on the outside. That doesn't occur. In order for this to combine with anything, I would just need a root 3 with no variable on the outside. That doesn't occur, which is why this is our final solution.